to work on the furnace, you're going to need some basic tools. One, you're going to need a 1/4 inch and 5/16 inch nut driver, and you're going to need a voltage meter, preferably one that has the ability to check capacitance. When the signal comes in from the thermostat calling for heat, the first thing that happens, that signal goes to this control board. Now this could be called a computer, it can be called burner control, it's known by several names. The control board is going to look out throughout the furnace to make sure all the safety switches are satisfied. If all the safety switches are satisfied, it's going to send power to this inducer motor. This inducer motor will start to spin and will send air up to the burner assembly, and will start purging any gases that could be inside this compartment. As it builds up air pressure, a pressure switch will recognize that there's adequate pressure or air movement up in the burner, and this will send a signal back down here to the circuit board. Once the circuit board is satisfied that there's enough air pressure, this will do one of two things. The first thing it will do, it'll send a signal back up to that device in the back. That is a hot surface igniter. The part that sticks into the combustion chamber will get really, really hot. The next thing that will happen, the circuit board will send a signal to the gas valve to open up. So gas will flow through the gas valve up into the burner assembly, up to the hot surface igniter, and will ignite. It's relatively pretty simple. Now that I've kind of walked you through the steps, we'll actually turn on the furnace and actually watch each step happen one at a time. So I have the power off here, so I'm going to go out to the thermostat and turn it on, and then we can turn the furnace on remotely at this switch here. Okay, we're going to go ahead and turn the power on. Now, because I interrupted the system, one thing's going to happen. The blower down here is going to go ahead and turn on and start purging the system with air, and it's going to run between 60 and 90 seconds. Okay, so we have this starting up, and it's going to create air pressure up in this area up here. When this senses the air pressure, it's going to send a signal back down to the circuit board that's ready to ignite. Now back in the corner is a hot surface igniter, and it's going to get nice and red, cherry red, hot enough to ignite the gas when the gas starts to flow. Gas valve open, and we have fire. Back in the corner, you can see this little rod sticking up about the same diameter as a hanger wire. That's the flame sensor. The computer is looking for that to get hot. If the flame sensor does not sense a flame, it'll shut down the entire system. That flame sensor will send back a signal back to the circuit board that the flame is present and everything is okay, and it will continue to heat your home. Okay, so I went ahead and turned everything off. That is a relatively simple explanation of what happens when you want to run your furnace and to heat your house. But what happens when your furnace doesn't run? So what we're going to do, we're going to go step by step to troubleshoot each component and how to test it, just in case your furnace fails you on a cold winter night. Just about every circuit board will have an LED light that will flash a code. Generally, on the back of each furnace door will have an LED code, depending on the types of flashes. When we go to turn this on, this LED light will start flashing 12. 1, 2, 1, 2. When you come back to here, you can see that it says blower on after power up, which is a common code when you interrupt the normal procedure of a furnace. If your furnace isn't working, the first thing you want to do is go to the thermostat. Now, it wouldn't be a bad idea at the beginning of the season to replace your batteries. If your batteries are low or not operating, you're not going to get any signal from your thermostat. So replace your batteries and also check your program. If everything works out on here, the next place you need to go is back to the furnace. Also make sure that your thermostat is not in the off position or the cool position. Make sure it's in the heat position. Each furnace should have a safety switch or cutoff switch nearby. This one right now is off, but make sure your switch is actually on. Funny story, my son-in-law bought a brand new furnace and one day it wasn't working. He couldn't believe that his brand new furnace that he paid thousands of dollars for wouldn't work. So he called up the repairman, complained. The repairman showed up to his house, and it turned out that one of the neighborhood kids turned off his switch, and all he needed to do was to turn the switch back on. So if you have little children, just make sure that your furnace switch is in the on position. You want to make sure you have power going to your circuit board. You should have an LED light that should be illuminated. If your light is not illuminated, check your breaker box to see if you might have a circuit breaker that has popped. The next thing to check is your inducer motor. This is the one that has to spin. It's usually the first thing that happens in the processes of starting your furnace. One of two things could be bad. One, your inducer motor could be bad, or the capacitor for the inducer motor could be bad. I want to do this little demonstration of what a capacitor does in connection with a motor. So I'm swinging this string and nut and using very little effort to keep it going. You can see my hand isn't moving very much. However, if I continue this motion, nothing happens. What a capacitor does, with its capacitance and the ability to store power, when the motor is first turned on, the capacitor is quickly discharged and gives an extra oomph of power, so to speak, to start swinging the nut. Capacitors are easy to test if you have the right equipment. I'm going to simulate what happens when a capacitor goes bad. I'm going to do this by removing the contact from the capacitor and then starting the furnace to see what happens. We're going to go ahead and turn on the furnace, and we're going to have to wait the 90 seconds for the system to purge itself. We're approaching 90 seconds, and at 90 seconds the fan below should turn off and the inducer motor should turn on. So this is when the inducer motor should turn on. If it doesn't turn on, the one thing you can do is take a look at the directions of the arrows and give it a bit of a spin. If it remains spinning without stopping, that is a sure sign that the capacitor is bad, but don't leave it in the state for too long. Go ahead and turn off the power. Before servicing a capacitor, you need to discharge a capacitor. A capacitor has capacitance. That means it has the ability to store power. If you touch these two prongs, you could get electrical shock. The best way to discharge a capacitor is to get a screwdriver and touch both contacts together to discharge the capacitor. You need to do this before servicing or testing. This capacitor, also known as the start capacitor, is 3 microfarads plus or minus 5%. So we have 3 microfarads plus or minus 5%. 5% equals 0.15. So on the high end, we're looking at 3.15. On the low end, we're looking at 2.85. This is where our readings has to follow. And just one other note, on a meter, you're looking for a symbol that looks like that. That is a symbol of a capacitor. So what we're going to do, we're going to test our capacitor, putting a lead on both ends here. Takes just a moment. Okay, so this capacitor comes up at 2.9. So if you remember our scale, 2.9 is within the range what we're looking for. So this capacitor is good. If it falls outside your range, then it's bad. If your inducer motor is bad, there are several videos on YouTube that will go further into testing inducer motors. They can be quite complicated. The one thing you'll want to do is to trace the wires of the inducer motor back to the circuit board and probe to see if you have 120 volts on the circuit board. If your inducer motor runs but you fail to get a flame in your combustion area, the next thing to test is your pressure switch, and these are quite easy to test. You will need an ohm meter. Remove the contacts and then follow the hose up to the T and remove the hose from the T. To test the air pressure switch, you're going to have to take the hose you disconnected and you have to put it in your mouth. Now, this may sound disgusting, but it's something you're going to have to do. But you want to blow very lightly. Do not blow hard. You could damage the diaphragm inside the switch. So you're going to get your contacts from your ohm meter, put it on the pressure switch, and blow lightly. You can hear the contacts and the tone from your ohm meter that this is working. So this tells me that this pressure switch is working as it should. Go ahead and reconnect the hose and reconnect the contacts. But let me warn you about using jumper wires as a bypass. They should only be used for testing only. You do not want to put your furnace into normal operation with a safety device being bypassed. You're asking for trouble if you do so. Once your air pressure switch is bypassed, try your furnace again and see if it starts up. If it does, that's a sure sign that your pressure switch is bad. If you ruled out your pressure switch, the next thing to test is your hot surface igniter, which is back in there. It's that white porcelain thing. And there's a plug right here where you can unplug this. So this is a plug that leads to your hot surface igniter. So what we're going to do, we're going to put our voltmeter inside here and see if we have power when it's time to ignite. Okay, we started the furnace up again. We got our voltmeter contacts inside the plug, and we have our voltmeter set up. Now this, what you're reading right here, is this random voltage right here. What we're going to be looking for is 120 volts at the time you hear the contacts click to send power up to the hot surface igniter. Okay, we hit 90 seconds. So we have the inducer motor running. It's going to be planning on going for that. Waiting for 120 volts. I just heard the click. Okay, we have 118 volts. Well, that's just fine. So that tells us that the circuit board is sending out 120 volts through this line up to the igniter. Now what's going to happen is it's going to attempt to light, but because it's not going to sense any flame, it's going to shut everything down. And there we go. Everything has been shut down because there wasn't a flame up in our chamber. If this were to happen to you where we get in 120 volts in our plug up here, but up in the chamber, the hot surface igniter is not getting cherry red, there's a good chance that the hot surface igniter is broken or is malfunctioning and needs to be replaced. Now we can do the same thing with the gas valve. Now just to note, there is an off-on switch on this gas valve. I can't think of any reason why someone would flip this off, but it should be in the on position. So what we're going to do, we're going to do the same thing we did with the hot surface igniter. The next step in the sequence is once the hot surface igniter gets hot, a signal will be sent to the gas valve to open up and to let the gas start to flow up to your burners. Now, if you were to hold your hand on this, you'll actually hear the solenoids actually click to open up the valves. So that's one telltale sign to look for. But another thing we can do, just to make sure you don't have a problem with your circuit board, we can also test for voltage at M1 and C2 here. So we're going to go ahead and disconnect these. And just like we did before, we're going to put our voltmeter, we're going to attach our voltmeter to these two leads. Okay, our leads are connected to from the gas valve, and we're just waiting for that 90 seconds for everything to go through its sequence. Okay, we're all hooked up to our voltmeter for the gas valve. Now, in our previous test, we were looking for 120 volts on the hot surface igniter, but in this case we're only looking for 24 volts. As you can see right here, it's kind of small, but it says 24V. So the gas valve only runs on 24 volts, so that's the voltage that we're looking for. So if you can take a look right now at our meter, we're pretty much at, well, this is like 3/100th of a volt. That's a stray voltage, but 24 is the magic number. So I'm going to go ahead and turn on the furnace, and we're going to go through the steps. Now this is registering 13 volts, but that's nothing to be concerned about because we're not in the proper sequence for the gas valve to open. We're looking for 24 volts. Okay, our inducer motor is wrapping up. So we're going to bring this back into the picture. Now remember, it says 13, but that's not significant. We're looking for 24. And we should also hear the relays opening to send the power up to the gas valve. Also, at the same time, as I'm holding this voltmeter, I'm also looking into the combustion chamber, looking for that hot surface igniter to go cherry red. It's going cherry red, so there should be a click here shortly. There's the click. and there's our 26 volts, 25 volts. That's exactly what we need. Well, it sensed that there wasn't any flame, so it shut everything down. So that tells us that we have power going to the gas valve. Now, if we have power going to the gas valve, but nothing ends up happening, then that would tell us that the gas valve would be bad. Now, gas valves are a little bit more complicated to replace. If I had a bad gas valve and didn't know how to replace them, I'd probably call for a service call, because a gas valve, not only is it part electrical, but it also has some plumbing issues coming into it. And if you're not familiar with that, that might be something you might want to call a technician on. Okay, so we've gone through the inducer motor, we've gone through the air pressure switch, the hot surface igniter, the gas valve. The only thing we have now is the flame sensor. The flame rod is one of the hardest sensors to get to because it's way back in there. That's a little rod that looks like about 1/8 of an inch in diameter. That sensor, when it gets hot, actually sends a small current back to the circuit board, telling it that it recognizes the flame, everything is happy, continue to run. So what we're going to do, we're going to disconnect that, and that is this white wire that's way back in the back. We're going to disconnect that and see what happens. Now, the flame rod doesn't accept power, it generates power, so there's no reason for us to try to probe for any power at this connection. It doesn't exist. The flame rod, by its nature, sends a certain amount of current back to the circuit board, so there's nothing here to test. In this case, we're going to go off the trouble codes. Okay, the inducer motor is turning. Soon our pressure switch is going to close, and we're going to get the hot plate igniter running, and then the valve, the gas is going to open to let things flow. Now, we will get a flame, but because I disconnected the flame rod, that flame will soon go out after it ignites. Okay, there's our igniter getting cherry red. The valve is open, the gas is flowing, and it's out because the flame rod is disconnected. Now, what's also happening is down here, we're getting a very unique code. We're getting a 3, 4, 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay, so we're getting a code 34. So we go over here. Okay, code 34 says ignition proving failure. So this will give you a hint on what to look for. Now, in this case, it lists the flame rod. They actually call this a flame sensor. So the codes that are generated off your circuit board are very important. So a bad flame rod or flame signal is going to be a code 34. Each major component in your furnace has its own unique code. Okay, remember our disconnected pressure switch that we did? Well, this is giving us a code 31. 1, 2, 3, 1. 1, 2, 3, 1. And if you go over here, it basically says a code 31 is pressure draft safeguard. So that'll kind of give you an idea of what's going on there. Okay, remember our disconnected hot surface igniter? That's giving us a code of 34. 1, 2, 3. 1, 2, 3, 4. If we go over here, ignition proving failure. So that gives you a hint on what to look for. Now a lot of times when you have an error code, the system will attempt to light the furnace 3 times or so, and after the 3rd time it'll just go ahead and shut down and generate the code. At the beginning of this video I mentioned that a signal comes into the circuit board, and then the circuit board reaches out to everything throughout the furnace looking for all the safeties to be closed. Now we didn't address that because it's unusual for these safeties to go out, but it can happen. Now one safety that can often go out is going to be the door switch. Now during this test I had to get a piece of tape and keep this door switch down. If you remove this bottom door here and this switch pops out, your furnace will not turn on. That's why I had to use a piece of tape to tape this down, or else nothing would have happened. Another safety switch is called the rollout, the high heat rollout switch right here. Now if fire were to leave the combustion chamber and settle in this area, heating up the back end of this combustion chamber, then this switch would be activated. Now the nice thing about this switch, it actually has a little button on it that you can reset. Another safety switch is way in the back there. That's another heat switch, and this is normally closed. And can be tested with an ohm meter. If you get a tone on your ohm meter, it's good. If you don't get a tone, that means it's open and bad. Same thing with your rollout switch. It is normally closed. If you're getting a tone, that is good. No tone would mean it's bad. Another thing that you might want to be aware of, and this is a point of housekeeping every year, is to check your condensate lines. Now, high efficiency furnaces give off a lot of water, and that water is collected down here in this water trap and flows down here to this little pump, and it looks like they have this hose going outside. Well, one thing you want to make sure that this pump works. It has a little float down inside. When the reservoir fills up, it'll turn on and eject the water outside. Sometimes you might have an inside drain that is where the water will be injected to. But it's not a bad idea to remove these hoses and just to make sure, clean things out. If water were to back up from the condensate trap back through these hoses, it's going to interfere with the pressure switch. So that's just one of those little things you might want to do each year, is to check to see if water is backed up in these hoses. Now another thing that could go bad is your big huge blower motor down here on the bottom. This too has a capacitor which can be tested. If you go to turn on your furnace and nothing happens at all, like we said, it should go through a 90-second or so purge cycle. If that's not happening, either your motor could be bad or this capacitor could be bad. So test your capacitor and then test for power going to your motor. Removing this is a little bit more complicated. You might want to call a technician. I hope this video has been informative. Don't be intimidated by your furnace. It's actually quite a very simple, it's a simple device. Basically you'd have to make sure all the switches are in the right place to send the gas up to your burner to light a fire. If you enjoyed this video, please subscribe, give me a like if you can, and I'll send more videos your way. Hopefully you might be able to save some money. Like I said, I'm not trying to teach you to be an HVAC tech. I'm just trying to educate you in making the right decisions at the right time. Knowledge is good.